Now see this question, how many two-state DFAs with a designated initial state and a designated final state can be constructed over the alphabet A comma B? Now if you see this question, they have clearly mentioned that two-state DFAs, which means our DFA is going to contain only two states. Okay, so if you try to write the table, the transition table for this, there will be, let us say, one state, let's name it as X, and other state, name it as Y. And now if you observe it, with a designated initial state and a designated final state, which means one of them is already designated as the initial state and a final state. So let us say this is designated as the initial state, and let us assume that this is only designated as final state, or this one is final state. You can take anything, but then they are saying that one of them is already designated as initial state. So once you designate X as initial state, you are not supposed to change it to Y, and once you designate Y as final state, you are not supposed to change it to X, right? And now they are saying that the number of inputs is, input alphabet is A comma B, therefore the input alphabet is A comma B. Now using this, how many DFAs are possible, that is given. Now here what are the options that we have is, we don't have any option in setting the number of states. I mean, in setting the number of states is already fixed, in setting the number of inputs it is already fixed, and we don't have any choice over the initial state and final state, they are already designated. Therefore only place where we can play is within this table, here the entries, right? So here the entries can vary, right? For example, here the entry can be either X or Y, which means capital X on small a can go to either state X or state Y. Similarly, capital X on small b can go to state X or state Y, right? Here also state X or state Y, state X or state Y. Now if you try to write this as as DFA normal convention, you are going to get two possibilities here, two possibilities here, two possibilities here, two possibilities here, right? So overall you are going to get 16, 2 into 2 into 2 into 2. Got it? Okay, now let's see a small modification to this. Assume that this word is not given, designated final state is not given. It is simply, let us say it is given that with a designated initial state, that's it, and nothing is mentioned about the final state. Then what will happen is, now we are going to get, let us say X is designated as initial state and nothing is mentioned as the final state. One possibility is there may be no final states in our DFA at all. This is one possibility. Other possibility is there may be one final state in our DFA, and that final state is, let's say, X itself. And the other possibility is there will be one final state in our DFA, and that final state might be Y. Or other possibility is there might be two final states, and the two final states might, both of them might be final states, right? So we are going to get these four cases. Got it? And now each case will give rise to 2 power 4, right? 16 DFAs. Therefore 16 here, 16 here, 16 here, 16 here, depending on how you fill these entries, right? For A and B, what are the transitions? You are going to get 16 for this, 16 for this, 16 for this, and 16 for this. Therefore it is going to be 4 into 16, which means 64. Actually this question is from permutations and combinations topic, but then since it is asked based on the DFS, we are solving it here. Okay.